between the celestial sphere and the earth. If we develop a relationship, we will be able to get some coordinates for the heavenly body on the earth, by which we will be able to find our position. So we saw that for a heavenly body which is rising north of the equinoctial, it has a northerly declination which is matching the arrows of latitude. And for the longitude, we said if we have a reference point, the green line is the Greenwich celestial meridian. Anything to the west of it or east of it also we can measure. How? By the hour angle. So what was the hour angle? Greenwich hour angle, because we are measuring it from the Greenwich. Arc of the equinoctial or angle at the pole measured westwards from Greenwich. And this also is, we can relate it to the longitude on the earth, because anything west of Greenwich is west longitude, anything east of Greenwich is east longitude. So where is the GHA of the body given? Sun, moon, planet, stars is given in the almanac. Yes or no?
Yes, sir.
So from the almanac we get two things very easily. We get the declination of the body and we get the GHA. So now you understand why we get those two from the almanac, because those two are relating us to the earth. How? I will show you an animated video on this one, so it will be more clear before I proceed further. But before I take you there, just listen to this one more point. If I draw a line from the center of the body to the center of the earth, like this, and in the case of the sun, let us say like this. What is this point called, where it intersects the earth?
Geographical position.
Pardon?
Sir, GP, sir.
Geographical position of the body. Okay, which means that the declination gives me the latitude of the body and the GHA gives me the longitude of the body as if it is on the earth. Now, which means it makes my job easier. Let us say I am at any one point on the earth and I get the latitude and longitude of the body. So I will be able to draw my position from that point on the chart. Yes or no? Earlier in the normal chart, you can see the mountain, the lighthouse on the chart, and you can plot your position. In the heavenly body, we could not see, but now if I have a method of bringing the body down to the earth, and somehow I am able to take a bearing of that body, will I be able to get my position or not? Logically, yes. Yes or no?
Yes, sir.
How we will do that and what is the theory behind it, that we will discuss later. There is still time to discuss that. But if I ask a layman a simple question on a chart, if I see something on the chart and I draw a bearing, a line from there, I get my position. In the case of a heavenly body, I could not do earlier because it was in the heaven and I was on the earth. But somehow if I am able to bring the body down and have a reference point, the geographical position of the body on the earth, on the map chart, then I should be able to draw my position also. Yes or no? So once this was established, then they started thinking now how to go about it. The logic they understood, that okay, we can do this now, but how to do it accurately and what is the actual procedure behind it, let us find out. So that is what decided later. At this point, what I will do, I will show you one animated video so that you are more clear on the celestial sphere. and then we'll proceed further. Are you able to see the screen?
Yes, sir.
Greenwich hour angle, declination and local hour angle. Yes?
Yes, sir.
Okay. Let us say this is the Earth, North Pole and South Pole. Direction north, south, east, west. This is the equator. These are the parallels of latitude. These are the meridians of longitude. This is the Earth. Equator 0 degrees. Northern hemisphere, southern hemisphere. Northern lat, southern lat, east longitude, west longitude, E lat, D long. And now we talk of the celestial sphere. There is the sun, there is the earth, and there are stars at various distances. This is not the final one, just have a look. The earth is rotating. And it is also revolving around the sun.
Yes, sir.
Yes, sir.
But like I said, since I am interested in my position, I will consider myself to be center of the universe or whatever I can see. And then from my position, because I'm interested in my position, I have to take this extent, altitude, the bearing. So I will consider myself as the center. So the sun is moving. The celestial sphere is also moving. You can see bodies rising in the east and setting in the west. East and west direction is mentioned. Celestial sphere is moving. Now, to establish a relationship between the Earth and the celestial sphere, the Earth is there with the equator, North Pole, celestial South Pole. Most of it I have explained, so it should not be difficult for you to understand. Wherever the body might be between the Earth and the celestial sphere, when you look at it, you cannot judge the distance. So we assume it is on a screen. That screen is like a dome in a planetarium. And a person in the northern hemisphere, wherever he is, he will be able to see only half of the dome. More about it later. So project the equator onto the celestial sphere, you get the equinoctial. Now the path of the sun. The next what you are going to see is the annual path of the sun, not the daily path. What I showed you earlier on the whiteboard was body rising in the east with the north declination and body setting in the west with the north declination. The parallel of declination was parallel to the equinoctial. You remember that one? The blue line and the red lines, dotted lines. That was the daily rising and setting of the bodies. What you are going to see now is the path of the sun on the ecliptic for the full year. So in this case, can anyone tell me what is the position of the sun? Is it rising, setting, north declination, south declination?
South declination.
South declination.
South declination. Is it setting or?
Setting.
Setting. Very good. So, if it would have been a daily motion, the sun would have risen on the eastern horizon below the equinoctial and set at this point along parallel to the equinoctial. So like this is the maximum southern declination, 23.5. Every day the declination will decrease, it will go up and up and up and come to the equinoctial. And after the equinox, it will become north declination. Then every day it will move from east to west till it reaches maximum north declination. But if I just draw the position of the sun at one point every day and I trace it, the path that will be traced will be this one, ecliptic. From south declination, it has come to equinox in 3 months, another 3 months to the summer solstice, another 3 months to another equinox, and finally after 1 year, it has come back to the winter solstice. Every day the sun may be rising in the east and setting in the west depending upon the declination. That is a different thing. But this is the annual path of the sun. In your homes, you must have noticed, if you are in an apartment or a house or wherever, in the summer, the sun is coming and giving sunlight in different rooms. In the winter, the sun is shining more on the other rooms on the other side. Has anyone noticed this one or no? Yes or no? Notice it now. Like my apartment is in a north-south direction in the sense, in my apartment I have got 2 balconies facing north and 2 balconies facing south. Nowadays what is happening? Nowadays is summer. So the northern balconies are having sunlight. Because sun rises in the northerly declination and sets in the northerly declination. East and west, no doubt. In the winter months, the sun does not come on this balcony. The sunlight shines on the southern balconies. So notice these things, you will understand what declination is. If you look at the sun rising every day, now when you go back to see, take a bearing of the sunrise and try to match it with the declination in the almanac. On the day of the equinox, the sun will rise exactly east, 090. But during the summer months, the declination will keep increasing, the rising bearing will change. How much will the rising bearing go to maximum? Anyone, gentlemen? Northern declination, rising bearing will increase or decrease?
So decrease. Decrease, sir.
Very good. On the day of spring equinox, the rising bearing will be 90 and the setting bearing will be 270. But as the sun is gaining northerly declination, every day you will notice the rising bearing will change. 89, 88, 87, 86, till it goes to how much? 67.5. Because 23.5 is the maximum declination north. After that, the rising bearing will start decreasing. Again, in September, it will become 0. And after that, the bearing will be how much? 100, 101, till it goes to 100, till it goes to, sorry, 91, 92, till it goes to 113.5, like that. So you have understood the concept now. What is the declination and how to figure it out. Very good.
सर एक क्वेश्चन था
Yeah.
सर इसी पिक्चर को देखकर कैसे पता लग रहा है कि सन इज सेटिंग
दोबारा बोलो जोर से।
सर इस पिक्चर को देखकर कैसे पता लग रहा है कि सन इज सेटिंग, जो अपन ने स्टार्टिंग में बात करी थी?
ईस्टर्न होराइजन किधर है? ऊपर देखो कंपास बना है, नॉर्थ साउथ ईस्ट वेस्ट।
हाँ सर।
तो ईस्ट तुम्हारे राइट में हुआ ना, इस स्क्रीन के राइट में ईस्ट हुआ
हाँ सर।
और लेफ्ट में वेस्ट हुआ।
यस सर।
तो अगर सन उस पॉइंट पे है लेफ्ट में, तो इसका मतलब सेट हो रहा है ना,
सर बट ये जो
है ना?
इक्लिप्टिकल है, ये अपना ईयरली पैसेज है ना?
ये तो एनुअल है, इसीलिए मैंने ये फिगर दिखाने के पहले बता दिया। अभी इफ यू वांट आई विल जस्ट स्विच ऑन द कैमरा, आई विल टेक यू बैक, तो तुमको थोड़ा समझ आ जाएगा। एक सेकेंड। बोर्ड दिख रहा है क्लियर या नहीं?
हाँ सर।
चलो अनशेयर कर देता हूँ। अभी दिख रहा होगा बोर्ड?
यस
यस सर।
ओके। अगर डेली पोजीशन हम देखें, मैंने पहले भी बोला था, अगर डेली पोजीशन में देखूं, सन अगर इधर है तो तुम क्या बोलोगे, सेटिंग है राइजिंग है?
सेटिंग है सर।
ये राइज यहाँ हुआ होगा, ये राइज इधर हुआ और सेट इधर हुआ। अगर इसको मैं स्लाइड के साथ मैच करूं, आज ये विंटर सॉल्स्टिस है, 23.5 डिग्री साउथ डिक्लिनेशन है। आज ये सन का मूवमेंट रहा। कल या थोड़े दिन के बाद जब डिक्लिनेशन थोड़ा कम हो जाएगा, लेटर से 15 डिग्री, तो सन यहाँ राइज करेगा और सेट यहाँ करेगा। थोड़े दिन बाद सन यहाँ राइज करेगा, सेट यहाँ करेगा। जब इक्विनॉक्स पहुंच गया, सन इधर राइज करेगा और इधर सेट करेगा अलोंग द इक्विनॉक्शियल। ठीक है, हैव यू अंडरस्टूड?
यस सर।
बट एनुअल में अगर मैं देखूं जो दूसरी डायग्राम है, तो सन का पाथ क्या रहा? सन का पाथ ये रहा। ऐसे जब नॉर्थ डिक्लिनेशन जाता जाएगा तो सन का पाथ, जब मैं एनुअल ट्रेस करूंगा, ये सन का पाथ बन रहा है। नाउ इज इट क्लियर?
यस
डेली
सर, वेल
पाथ तो
अंडरस्टूड
ये
नाउ।
है, ये एनुअल पाथ चल रहा है। समझ आ गया?
यस सर।
ओके, लेट अस गो बैक टू द एनिमेशन नाउ।
होल्ड। हाँ बोलो।
क्या?
शैल आई मूव ऑन?
नहीं मिस थोड़ी ना, देम दे।
माइक
अरे
म्यूट
माइक
कर
बंद
लो,
कर लो
कौन
भाई
बात
साहब।
कर रहा है? पे अटेंशन टू द क्लास। ये सारे इंपॉर्टेंट हैं, फिर बाद में।
हम
ओ जाफरी साहब माइक ऑफ कर लो।
ओके, लेट्स मूव ऑन। Coming back to this diagram, let me go back. I think I will use this mode. Okay, अभी थोड़ा आवर एंगल्स देख लेते हैं जो भी हम डिस्कस कर रहे थे। So the equinoctial, the earth in the center, celestial sphere around it. This is the parallel of declination, body rising in the east, setting in the west, daily path. This is the declination. Let's say this is the Greenwich meridian now. The point of reference. We can make 3 points of references. One is the Greenwich meridian, or the meridian passing through Greenwich. This is just a celestial meridian passing through anything, maybe. एक meridian ही दिखाया है. स्टार बना दिया ऊपर में, येलो स्टार. So if that meridian is passing through the star, and if I want to measure the declination and the Greenwich hour angle, it is marked by that blue and the red arrow. The arc of the meridian, I am defining declination. The arc of the meridian or angle at the center of the earth between the equinoctial and the parallel of declination is the declination. And for the Greenwich hour angle, the arc of the equinoctial, the red one, or the angle at the celestial pole between the Greenwich meridian and the meridian passing through the body measured westwards. Our angles are measured westwards. So what I had shown on the board and up to this point, you have any question, gentlemen, before I proceed further? Is this part clearly understood now?
Yes, sir.
Okay. If I draw a line from the star to the center of the earth, it will enter the earth at that point where that arrow thin line is there. That you rightly said earlier, it is the geographical position of the body, which will be matching with the latitude and the longitude. Geographical position. So now I have successfully brought the body down onto the earth and I have a reference point. So I may be at any point on the earth as an observer, and from there if I am able to measure this distance and the angle, I'll be able to get my position. Okay, now let us see further how we investigate. This was the declination, this was the GHA. Now the Greenwich meridian is on the side. This was the geographical position. We come to another important point here now, since it is in the slides, let us go through it. Make a note of this, gentlemen. Always take some notes if you want. I had said earlier that the distance from the equinoctial to the celestial pole is 90 degrees. Now the declination is given in degrees. By now you know in the almanac. Yes or no?
Yes, sir.
So in this case, let us say approximately the declination is 70 degrees. It is very high. So I'm saying 70 degrees. What is 90 minus 70?
20.
20.
Sir.
So the polar distance we call 20 degrees. Polar distance means the distance of the body from the pole. So write down this relationship. Polar distance is equal to 90 degrees minus declination. When we do the PZX triangle, it will be very important for us to understand all this. You must have already started doing it in the great circle. P is the pole, X is the star body, and what is Z?
Zenith.
Z is the Z. Oh, very good. PZX triangle. So declination, 90 minus declination is the polar distance. Let's move on. Here we have the equinoctial, the black semicircle, and red is the ecliptic, and where it intersects is called the first point of Iris. It's an imaginary point far out in the space, infinite distance. Earth is in the center. I can draw a meridian through the first point of Iris. This is my second reference point. Which was the first reference point for the longitudes? For the hour angle, GHA hour angle, it was the Greenwich meridian. So with Greenwich meridian as the reference point, I could measure the Greenwich hour angle measured westwards. Now I have another reference point called the first point of Iris. So meridian through Iris. There's a star over here, a meridian through the star, meridian through the body. So what is this angle called? Measured westwards from the first point of Iris. All hour angles are measured westwards. It is called sidereal hour angle. Earlier on I had asked you a question. Some of you replied. For the planet and for the moon and for the sun, the GHA and declination is given in the almanac. What is given for the stars?
SHA
Also,
and declination.
SHA and declination is given for the stars. SHA and declination is given for the stars. Why GHA is not given? SHA is given.
First point of Aries.
Any idea? No. We will see that later. You see, because the GHA keeps changing, but SHA does not change. Because the first point of Iris is an infinite distance, it remains fixed. So both are infinite distance, the star also and first point of Iris, and we said earlier that they are so far away that they don't move at all. So even if you look at the almanac, you will find that both the points are not moving at all. Look at 1st January and 31st December. You will find it is almost the same, only very slight difference. Why there is a slight difference, that we will discuss in a later chapter. But for the time being, if we would have given GHA for every star, how many navigable stars are given in the almanac that we use for navigation? 57. So then imagine if GHA for 57 stars is also given, how bulky and how big the almanac will become. So it will be very difficult to use. So we give SHA for the star. So this is the sidereal hour angle. Definition: the arc of the equinoctial or angle at the pole between the meridian of the first point of Iris and the meridian passing through the body measured. Which side?
So westerly.
westward.
Measured westwards. Okay. So read the definition in the books. It will be something similar. So this is the declination and the polar distance. In all the formulas of practical navigation, we will be using all these things. So mentally get the picture in a three-dimensional way very clearly. It will be very easy for you to understand. Okay. Now we come to another dimension. By looking at this picture, can you tell me what I am seeing? What is that circle representing?
Rational horizon.
Anyone can tell me?
The circumference of the Earth at equator.
Circumference of the Earth at the equator. Very good. What is your name?
Divyansh, sir.
Divyansh. You are doing most of the answering because I cannot see who's answering now. Are you the one who's answering most of the time? Or there's somebody else also? Okay. I think I recognize 4 or 5 voices generally who are answering. So my suggestion to the others is also to read and pay attention. Why do you say that it is the equator?
Sir, because pole is at the center.
Pole is at the center. We see the stars and the first. So let me correct myself. This is the celestial sphere. This is the celestial sphere because on the border there is one star There is first point of Eris. And there is P in the center. This is the celestial North Pole. So I'm looking at the celestial sphere now. Remember, celestial sphere is of infinite radius. But I am going beyond that and having a look. I'm looking down now from the celestial sphere. Is this point clear to everyone? I'm looking down from the celestial sphere at the North Pole.
Yes, sir. Yes, sir.
So since the Earth is round, after the equinoctial, it is curving inside, so I cannot see beyond that. Is that also clear? Yes?
Yes, sir.
Now, because my vision is bounded by the equinoctial, I want to give a name to this diagram. What should I call it? This type of diagram is called the equinoctial horizon, or equinoctial diagram, equinoctial horizon, let us say. Equinoctial horizon. Now imagine you are standing on that pole. Imagine you are standing on the pole. Let us say you are standing on the North Pole of the Earth. You are standing on the North Pole of the Earth at night, and you see a dome above you. Half of the dome you are seeing, half of the circle full. Huh? So what is the limitation? What is the limit of your horizon on all the sides? What is the limit of your horizon on all the sides? If you are standing on the Earth at the North Pole, on top of you is what? The celestial North Pole? Yes?
Yes.
Yes,
On
sir.
top of you is the celestial North Pole. And what is on the horizon? Your horizon is bounded by the equinoctial. Yes or no?
Yes, sir.
So that is why we call it the equinoctial horizon.
Yes, sir.
Yes, sir.
What type of stars you will see if you are on the North Pole at night? One thing is sure that you are seeing only half of the hemisphere. You are seeing which part of the hemisphere?
North part.
The northern celestial sphere you are able to see, correct? Very good.
Yes.
Earth is rotating west to east. So at night, what stars will you see? Which part of the sky and the stars you will see? You will see all the stars which are having north declination only.
Yes, North declination.
They will be going round
Yes.
and round you because you're in the North Pole. You can see everywhere, all directions you can see at one time. You will see they will be just going round and round you. Yes or no? Imagine, you can imagine, no, you're on the North Pole. All these stars going round and round you. You will not see any stars of the southern declination because they are beyond the curvature of the Earth. So this diagram is very important, gentlemen. Equinoctial horizon for you to understand the hour angles. Okay. Now tell me, what is that line P below P mean? P to the Greenwich meridian. What does it mean?
Prime meridian.
It is a meridian, prime meridian, celestial Greenwich meridian. But you are able to see only half of it because the other half is gone down. From celestial North Pole to the equinoctial, you are seeing the Greenwich meridian. It is a straight line. In this diagram, all the great circles are straight lines. Imagine the projection. The half of the equinoctial, if you spread it out, they are all straight lines. The other side is the inferior meridian of Greenwich, 180 degrees. The other side, of the globe. Okay, I think you are getting a very good and clear picture of what I'm trying to explain. It becomes a little difficult to explain online without the proper, once you're in the class, then slightly different, but I'm satisfied with the progress you people are replying. So I draw one more meridian from P to the first point of iris. Again, it is a great circle, but represented by a straight line. Remember in the previous slide, you saw first point of iris, how the meridian was going from there. If you have any doubt, I can take you back. Anyone has any question, you must ask. So GHA iris. Let me repeat the definition. The arc of the equinoctial or angle at the pole contained between the meridian passing through Greenwich and the meridian passing through first point of iris measured
Westerly.
Westerly.
Measured westwards. So earlier the GHA we had seen sidereal hour angle. Yeah, this was the GHA earlier. We were seeing from the side. Now we are seeing from the top of the NCP. Now we are seeing from the top of the NCP. So GHA star SHA star, we will come to this. So now I'm seeing the pole from the top. So I have got GHA iris. If I draw a meridian through the star and I measure it from the first point of iris, like in the previous slide I just showed you, it is SHA star. You see this one? Arc of the equinoctial angle at the pole between meridian of iris, meridian of the star measured westwards. The same picture now I'm seeing from the top. SHA star. Any doubt, anyone? So I have GHA iris, I have SHA star. If I add the two, I have what? GHA star.
Yes, sir.
Anyone has any doubt here? Please ask. Is this statement correct? GHA star is equal to GHA iris plus SHA star.
Yes, sir.
GHA star is equal to GHA iris plus SHA star. You can see the relationship now. So just ignore that iris example GHA. I think it is intentional over there. Okay. If GHA iris is equal to 110 degrees, SHA star is equal to 90 degrees, GHA star will be 200 degrees. So this is a very simple equation. Any question, gentlemen, on this equation? Anyone? I think it's very clearly explained over here. Okay. Let us do another. What has changed in this diagram now?
So first point of iris.
First point of iris has come from the western side of the Greenwich. It has come to the eastern side of the Greenwich now. But remember, in the hour angle, we don't have east or west. In the longitude, we are measuring only 0 to 180. 0 to 180 east, 0 to 180 west. But in the hour angle, we don't do east-west. We measure from 0 to 360 degrees. So if in this slide, GHA iris was 110 degrees. In this slide, it is how much approximately? About 320 degrees. About approximately. Am I right?
Yes, sir.
So the hour angle is measured from 0 to 360. Remember that one. GHA iris. SHA star. Now the earlier equation was simple. Here there is some confusion. Slight overlapping here and there. But no problem. The equation remains the same. GHA star. The equation remains the same. How? Let us see. GHA star is equal to GHA iris plus SHA star. If the answer is more than 360, what you will do? GHA iris is about 300 degrees. Follow the black line. GHA iris 300 degrees. SHA star is equal to 270. Red line. So GHA star is equal to you minus 360 if it is more than that, so it becomes 210 degrees. Take a few moments to see this diagram properly. If you want, you should draw on your notebooks also. If you draw, it will be imprinted in your mind. Don't go too much by recordings. I will see again when I have time. This particular focus, what we are sitting and doing, you will never get again. Remember that. So GHA star is equal to GHA iris plus SHA star. If you are done with this, I will move on. Any questions, anyone on this, gentleman? Okay. So let me move on. I hope you have written the formula and drawn the diagram. This one is over, then maybe we can move on. The angle measured westward between the meridian of the observer and the meridian through the body. We come to the third reference point now. For longitude, we had the Greenwich hour angle measured from Greenwich. Greenwich is a fixed reference point. So we had Greenwich hour angle, we had sidereal hour angle from the first point of iris. Meridian passing through first point of iris. But I am the observer. It is very important for me to find my position. Greenwich is fixed, first point of iris is fixed. They can be the reference point. But I, as an observer, I am moving on the ship along the globe. So at every point of time, the GHA and SHA, everything is changing, no? So I come to a third reference point, LHA, local hour angle. Local hour angle. Only if I know the local hour angle from the body, will I know the position. The relative position of the body from SHA, GHA is okay, but then how far I am from the body, local hour angle. That is also very important. The hour angle, the angle measured westward between the meridian of the observer and the meridian through the body. So now what is the difference in this diagram over here? We do not see first point of Aries. Instead of that, what do we see? We see the observer. So I can draw a meridian passing through my observer's position. On the Earth, it will be latitude and longitude. But if I extend my position to the celestial sphere, what will it be called? A line joining from the center of the Earth, passing through the observer and hitting the celestial sphere. What will it be called?
Zenith.
Zenith. Very good. So if there is a meridian passing through that, we will call it meridian passing through the observer. So if there is a meridian passing through the observer and I measure it westwards from the Greenwich meridian, what do I get, gentlemen? I get my longitude. Yes or no?
Yes, sir.
Very good.
Yes, sir.
The blue one is the GHA star. We already saw that. Yes or no?
Yes.
GHA of the body, GHA of the body is very easy to find. No, you're getting from the almanac. If it is a star, then we already saw the relationship. GHA star is equal to GHA Aries plus SHA star.
SHA star plus GHA.
GHA Aries plus. So in the almanac, what is given? GHA Aries is given, no?
Yes, sir.
So from the almanac you get GHA Aries, and from the almanac you get SHA star, and for that particular time you get GHA star. So if you are getting GHA star from the almanac, and we will see what is LHA, and then we get our longitude. What is LHA star now, the red one? GHA was from the meridian of longitude, Greenwich. SHA was from the meridian of first point of Aries. LHA is from the meridian of the observer. So the arc of the equinoctial, or the angle at the pole between the meridian of the observer and the meridian passing through the body measured westwards, is called the local hour angle. Because as an observer, for me that is important. So now what is the relationship we are getting, gentlemen? Very important. LHA is equal to GHA minus west long. Write this, very important. LHA is equal to GHA minus west long. So if you know LHA, GHA, you can find the longitude. Very simple. GHA you will get from the almanac. LHA how we will get? Anyone? There are some people who are giving advanced answers they have read. I think they are quite knowledgeable. How do you calculate LHA at sea? That is what you do in the site, you know, the extent, angle P. We will come to that later. No problem if you are not able to answer. But at this point, the thing which I was trying to tell you was, our intention is to find the longitude of our position. GHA you get from the almanac. Where do you get your LHA from? That is what you get from the site. We will see those things later in practical navigation. But understand the relationship. At the beginning of this session, what I said, we are trying to establish the relationship between the Earth and the celestial bodies and the celestial sphere. So, how to bring the body down, how to measure the angles is what is our intention over here. It is a combination of the system on the Earth and the system of the celestial bodies. When you join these two by taking a sight by a sextant and the bearing by the azimuth, and you work out the site, you get your position. That is the whole science and theory behind it. So this formula is very important, gentlemen. LHA is equal to GHA minus west long. But observer may not be in the west longitude always. He may be also in the east longitude.
East.
Then what? So we have an observer
GHA
in the east
plus
longitude.
longitude is.
Pardon?
We will add the longitude.
Yeah, we have an observer in the east longitude now. Longitude east. Let us see how the formula will work out. GHA star. Longitude east. LHA star. So now LHA is equal to GHA plus east longitude.
Plus east longitude, sir.
In the earlier case, what it was? LH is equal to GHA minus west long. So now we have LH is GHA plus east long.
Plus west long.
So we write one formula, LH is equal to GHA plus east minus west long. So any questions so far till over here, gentlemen? The main important point you have to remember is we have got three. For latitude, we have one reference point from the equinoctial, so that is the declination. And for the finding out the longitude, we have three reference points: GHA, SHA, and LHA. So the angle, the hour angle of the body, we can measure from any 3 points, either GHA Greenwich, SHA first point of iris, or LHA from the observer. Then we combine them somehow and try to find our position. Whatever is available. If it is star, we will go for SHA. If it is body, we directly go for GHA. Okay, now what is this? This is the observer. Let me just have a look how many slides there are and what is the topic now. Okay, finishing now. Good, let's finish this. So once again, we have the meridian passing through the observer. What is that small circle in between, gentlemen? That is the pole, huh? That is the North Pole. That is the pole not mentioned here. So let us say a body is rising in the eastern horizon. What will be the LHA of the body? Local hour angle, approximately 270. Because you are measuring from the observer meridian to the body measuring westwards. The next picture will be a little more clear. Body on the meridian, LHA is equal to 0. If there is a body on the meridian, the body is not shown here. I will try to figure it out, try to put it. LHA 0 bearing north or south. Body setting, LHA 90. Remember, I am not saying bearing 90. I am not saying bearing 270. I am saying LHA. Rising bearing will be 90. Setting bearing will be 270. But we are saying LHA. LHA is measured westwards from the observer. Here LHA is 180. Actually, this slide is made to show something different. If LHA is 0 to 180, if the local hour angle of the body is 0 to 180, the body lies to the west of the observer. These are important statements which will help you in your numericals and theory. So understand and make note. If the LHA of a body is between 0 and 180 degree, it means the body is lying to the west of the observer. I am not saying it is lying in the western longitude. I am saying the body is lying to the west of the observer. Observer may be 90 east. Body may be 70 east. LHA is 20 degrees. If LHA is 20, no one will mention east or west. LHA is either only degrees from 0 to 360, I said. So if LHA is 20 and observer is 90 east, what is the angle of the body or whatever? 70 east. So if the LHA is between 0 to 180, the body lies to the west of the observer. This point is clear, gentlemen, or anyone has a question? If the LHA is between 180 to 360, if the LHA is between 180 to 360 degree, then body lies to the east of the observer. Don't confuse longitude with this. We are just saying body is lying to the east of the observer or body is lying to the west of the observer, depending upon the LHA. So I hope you have followed whatever I have been trying to say today. I would strongly urge all of you to read the Celestial Sphere chapter. If you have not already done so, read it again once, twice, thrice. Draw the figure, draw the diagrams, and try to understand as much as you can. If you have any doubt, we will discuss tomorrow. Otherwise, I will continue with the chapter. The topics may be slightly different. Today we have understood the shape of the celestial sphere and we have done the equinoctial horizon and we have done the hour angles. Equinoctial diagram means looking from the top of the pole and from all the three reference points, Greenwich, Iris and observer, we have drawn the hour angles and we have seen what is GHA, what is SHA and what is LHA. And we have also seen how to calculate the longitude by that formula. LHA is equal to GHA plus east minus west longitude. So with that we come to the end of this session, gentlemen. You can go for a 15 minutes break and come back after 15 minutes. Is that okay?
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.